Hello everyone. Today I'll be discussing my project on change detection in hyperspectral satellite imagery using fully convolutional networks and 3D FCNNs. So the motivation behind this problem is that when we have the satellite images, it you know takes hyperspectral images, and the hyperspectral images do have the capacity of detecting change. So why change detection is important is that the surface of the earth is undergoing constant change due to several man-made activities and due to natural disasters, and using the satellite images and the deep learning techniques to detect change would be a cool problem to solve, because it can help the policymakers to come up with good responses against things like deforestation or urbanization. And also, in case of several natural disasters, we need some appropriate policies so that we can provide the help that is needed. So this is a cool problem to solve, and in this project I'll be discussing how 2D fully convolutional networks can be used, and how 3D fully convolutional networks can be used, and then in the end comparing the performance of both. So for this I'll be using the OSCD dataset that has been implemented in TorchGeo. So it contains 24 pairs of Sentinel-2 satellite images with 13 spectral bands, and the output is mask, where 0 is there's no change and 1 stands for there's a change. So I'll be using this dataset that has been implemented in TorchGeo. It seamlessly integrates with PyTorch. So these are the fully convolutional neural nets that I'll be experimenting with. So these architectures are based on the UNIT architecture. So the early fusion stacks both the input images at the beginning itself and the Siamese concentrated one. What it does is during the up convolution, it concatenates the feature that is extracted during the encoding part, and for the Siamese diff, it subtracts the features that are extracted during the encoding part. Yeah. So both, I would say, all the three models are based on UNIT. It's just minor changes that's happening to the Siamese conc and the Siamese diff. So going forward, the 3D FCNN that I'm talking about is also based on the UNIT architecture. But I think that since 3D FCNNs have 3D kernels, so it will be able to learn richer signals from the satellite images, and satellite images has both spatial and spectral information. So I'm thinking of leveraging both. So the experiments that I'll be conducting is, I have extended the data set. I've created some augmented data set by flipping the images and also rotating the images. And then I do have a test set that comprises of 10 images that is from the Onera dataset itself. And I'll be evaluating my models on precision and accuracy. So after training, I can see that the 2D FCNN that were discussed in the earlier paper, that performed the way it performed was good, but the 3D FCNN was able to perform equally well with just half the number of training epochs. We can see that reflecting in the precision and the accuracy. So my hypothesis of using 3D FCNNs, I think that has been a correct hypothesis, because it is able to learn richer signals from the hyperspectral images. Thank you.